Hey guys, good morning. Here's a video for the Chapter 8 closure worksheet, which is just a worksheet that summarizes the work that we've done so far this chapter. As with the other videos, I'm going to do the first part so that you know how to get started, and then if you have further questions, you can email me, send me a message on Parent Square, or set up a Google Meet video call. Okay, here we go. Number 1, factor and use the zero product property to find the roots of the following quadratic equations. Factor means use the generic rectangle and the diamond problem to write this sum as a product. So let's do that first. X squared here, 12 up here. X squared times 12 is 12x squared. What goes on the bottom of the diamond? That would be negative 7x. Negative 3x and negative 4x, multiply to 12x squared and add to negative 7x. So put these into the missing parts of your generic rectangle. Find the length and the width. X times x is x squared. X times negative 3 is negative 3x. X times negative 4 is negative 4x. And just to double check, negative 3 times negative 4 is positive 12. Okay, put your length and your width here. Using the zero product property now means taking each factor, setting it equal to 0, and solving for x. So for example, I'm going to take x minus 4 and set it equal to 0, and I'm going to solve for x. If you add 4 to both sides, get x equals 4. Do the same thing with your other factor. Take x minus 3, set that equal to 0. If you add 3 to both sides, I'm going to get x equals 3. Okay. Typically, we get 2 solutions for x. Sometimes, I believe in part D, you'll get 1 solution for x. Okay, so this is all you have to do for number 1. Factor, use the zero product property to solve for x. Number 2, graph y equals x squared minus 2x. Identify the y-intercept, the x-intercepts, and the vertex. You want to start creating points by making an xy table. In this case, maybe start from negative 3 and go all the way out to positive 3. The way that we get the y values is we take each x value and we plug it into the original equation. So for example, to get the y value, that goes with negative 3 for x. We take y equals x squared minus 2x, and we plug in negative 3 for x. So negative 3 squared minus 2 times negative 3. I need these parentheses. They're pretty important. Why? Because negative 3 squared is positive 9. Be careful, it's not negative 9. Negative 3 times negative 3 is positive. And then here, negative 2 times negative 3 is positive 6. So we get 15. Okay, now let's plug in negative 2. Negative 2 squared is positive 4. Negative 2 times negative 2 is also positive 4, so we get 8 here. And then you're just going to keep doing the same thing so you get all of your points. Plot those points on the graph. Sketch your parabola. Make sure to identify all of your intercepts, the x-intercepts, the y-intercept, and the vertex. Okay. Here for number 3, find the coordinates of the y-intercept and x-intercepts of y equals x squared minus 2x minus 15. Show all of the work that you used to find these points. We don't have the graph here. I will tell you this. This equation is in standard form. That was in one of the CPM assignments you've done before. It had a little math notes section about factored form and standard form equations. And in standard form equations, when you have something times x squared plus something else x plus something else, I'm not being like super math correct in my explanation here, but this last term is your y-intercept. So if you were to write your y-intercept as a coordinate, that would be 0, negative 15. y-intercepts as coordinates are always written as 0, comma, and then the number of where the graph intersects the y-axis. So this is how we would write the coordinate of the y-intercept. To get the x-intercepts without graphing, all you have to do is factor. Okay, so you take y equals x squared minus 2x minus 15. Use a generic rectangle and a diamond to factor. I'm going to do this fairly quickly since we've had a lot of practice doing this so far. Okay, rewrite this as a product length times width. Okay, to get the x-intercepts, use the zero product property. So we're going to set this equal to 0. We're going to set each factor equal to 0. Why do we even do this? Because if you're multiplying two factors and you get 0, well, one of them has to be 0. When you multiply something to 0, you get 0. So either x plus 3 is equal to 0 or x minus 5 is equal to 0. If you solve for x, subtract 3 from both sides, you get x equals negative 3 as one of your solutions, or you get x equals 5 as your other solution. So your coordinates for your x-intercepts would be negative 3 comma 0 and 5 comma 0. That is why we are using the zero product property to reveal information about the function. So if you wanted to graph this, which you don't have to, let's see, 0 comma negative 15 would be somewhere down here. Negative 3 comma 0 would be somewhere up here. And 5 comma 0 would be somewhere over here. So if you did want to sketch the graph, it would look something like that, okay? And we did all of this without even making a table. All right, moving on. Here for the zero product property, you're going to do the same thing that you did in number 1, except maybe these are already factored for you. If they're not factored, make sure to factor them. Also, make sure that they're set equal to 0. Here we have equals 9. We can easily fix this by just subtracting 9 from both sides. Now we have 0 equals 3x squared plus 4x minus 15. We can factor, see, 3x squared down there, negative 15 up there. 3x squared times negative 15 is negative 45x squared. 4x would go down here. Now what adds to 4 and multiplies to negative 45? That would be 9 and negative 5. 9x plus negative 5x is 4x. 9x times negative 5x is negative 45x squared. I know sometimes just solving the diamond problem can be difficult. Let's see. When we find the length and the width of this generic rectangle, aka when we factor, we get 0 equals 3x minus 5 times x plus 3. And now set each of these pieces equal, each of these factors equal to 0 and solve for x. Okay. So this is already factored for you. Just set each of those factors equal to 0. This is not factored, so factor and then set equal to 0. Number 5, which equations below are equivalent to this? Look at each expression, simplify step by step, and see if it's equivalent. So try distributing this 1/2 and see if that leads you to one of these options. If it is equivalent, you would circle it. If it's not equivalent, you would cross it out. Okay, so that's my hint there. Here you're just going to factor. For number 6, I will give you a hint. For B and D, notice that we have extra x terms. Instead of having x squared, x, and then a constant term, we have x cubed, x squared, and x. So you're going to need to factor out the greatest common factor first, and then factor. For example, I'm going to factor out an x for part D because I have an extra x term. Also, notice that 2 goes into 6, 10, and negative 24. So if I factor out 2x, the greatest common factor, the resulting quadratic will just be easier for me to factor. So if I factor out a 2x from 6x cubed, I'm left with 3x squared. Okay, 2x, whoa, what happened? 2x times 3x squared will give you 6x cubed. Okay, and then plus 5x, 2x times 5x is 10x squared, minus 12. Okay, 2x times negative 12 is negative 24x. And then you would take this and you would factor, again using a generic rectangle and a diamond. I'll do this part with you. Let's see, 3 times negative 12 is negative 36x squared. Positive 5x. This one's a little tricky. I want to say, yeah, 9x and negative 4x. 9 plus negative 4 is positive 5. 9 times negative 4 is negative 36. So we would put these back into the generic rectangle. 3x and x multiplies to 3x squared. 3x times 3 is 9x. X times negative 4 is negative 4x. So once you write the length and the width, you are finished. Okay, that's all you have to do here. And last but not least, for number 7, solve each quadratic equation using a specified method. For factoring, again, you're going to rewrite this sum as a product, length times width. And then you are going to solve for x. Here, you may need to use a table to be able to graph. And then once you graph, find your x-intercepts. This is just a sketch. This is not accurate. You're going to need to find the points yourself. Okay, let me know if you have any questions, and have a good day.